Hi, welcome to this presentation on introducing a cost-effective radiopaque scale design for intraoperative use. I'm Roopam and my co-authors are Mr. Giancarlo Beukes, Mr. Gokul Nair, and Dr. Sudesh Sivarasu. This work has been performed at the University of Cape Town Orthopaedic Biomechanics Lab in collaboration with Impulse Biomedical, a UCT spin-off medical device company. Radioopacity is the property of any material that restricts the passage of radio waves such as X-rays. This helps them to get detected by the X-ray and can form an effective guiding tool or referencing tool during orthopedic surgeries. Scales, which have embedded radiopaque material like the one you're seeing on your screen now, is used during orthopedic surgeries. Such scales are very specific. For example, the one you're seeing now is used for MPFL surgery, that's medial patellofemoral ligament surgery, and they cost around 1300 US dollars or around 25,000 South African rands, and they have to be bought with the whole kit. Therefore, these MPFL surgical scales cannot be easily used for any other surgery. In the market, there are standalone scales like the ones you can see now, but they cost a lot of money and it doesn't make sense to use them for surgeries in developing countries such as South Africa. Therefore, we wanted to use cost-effective, off-the-shelf, biocompatible materials such as barium sulfate and iodine dyes, which are commonly used as contrast agents during medical imaging and test their radiopacity. We designed two square-shaped scales. They had longer grooves 10 mm apart and shorter grooves were 5 mm apart from their adjacent longer grooves. Each groove was 2 mm deep, and we filled the grooves in one scale using barium powder and on the other scale using iodine dye. The total manufacturing cost of these scales were around 50 South African rands or $2.60. To analyze the radiopacity of the materials, we took radiographic images of both the scales and compared them to a radiographic image of a piece of metal. The imaging was performed using a low-dosage X-ray device developed by Lodox South Africa, and the image analysis was performed using MATLAB. From the image analysis, we observed that the RGB values of barium-filled region was as bright as the metal under the scanner, suggesting superior radiopacity when compared to a iodine-filled scale. We have recently successfully implemented such barium-filled scales on few of our innovative medical devices. We have used it on Patrick, a device which guides surgeons to drill parallel holes into the kneecap, also known as the patella, and the laxmeter, which is a knee joint ligament laxity measuring device with the ability to measure the ligament laxity of all four major ligaments in the knee. In conclusion, we have successfully developed and implemented a cheap and easy to manufacture radiopaque scale that can be used in orthopedic surgeries and testing setups in developing countries. The authors would like to acknowledge Mr. Charles Harris and Mr. Tyron Leavitt for their timely assistance with manufacturing and design inputs. Without them, this project would not have been possible. Finally, we would like to thank the organizers of DMD who have gone out of their way to give us an online platform to showcase our work. If you have any questions and queries, please feel free to contact our corresponding author. Thank you.